Good day, everybody. My name's Steve B. I'm the Group Commercial Director for VPS. I'd like to offer thanks to Llewellyn, Leslie, and the Petrospot team for giving me the opportunity to share my presentation with you today, and also for VPS to sponsor a conference which is close to our company values. For VPS, sustainability is at the heart of our business and our culture. It's what drives us forward. It's how we deliver on our purpose to protect our customers, their assets, their people, and the world around us. So today I'd like to share our thoughts on how our services can help ship operators achieve the environmental targets which are set for the industry. The maritime sector emits to atmosphere 940 million tonnes of carbon dioxide per year. It contributes 3% of global greenhouse gases, and black carbon, accounting for 21% of CO2 equivalent emissions, comes from ships. For some time, the IMO have been working to improve the environmental impact from shipping. Back in 2005, the IMO introduced the MARPOL Annex 6 to regulate the air pollution being emitted by ships, including the emission of ozone-depleting substances, NOx, SOx, and VOCs. The successive introduction of ECAs and reductions in sulfur levels both globally and regionally over the past 15 years is having the positive impact required. However, IMO has now set targets to reduce greenhouse gas emissions from shipping by at least 50% by 2050 compared to the 2008 levels, and also reduce the carbon intensity of emissions by 40% by 2030 and 70% by 2050, again compared to the 2008 levels. This actually equates to reducing greenhouse gas emissions by almost 500 million tonnes over the next 29 years, which is actually not a long time frame. There are many possible contributing solutions to reducing greenhouse gases and CO2, such as vessel speed optimization, hull design, propulsion system design, voyage optimization, and energy management. But fuel type will be a major significant factor in the reduction of greenhouse gases and CO2 emissions. The United Nations Sustainable Development Goals, or SDGs, are recognized as being essential to the future sustainability of the world. They represent an action plan for the planet and society to thrive by 2030. IMO, shipping, and the bunker industry all have a responsibility to contribute to the UN Sustainable Development Goals. But testing companies also have a role to play. In VPS, we contribute significantly towards the delivery of 4 of the UN Sustainable Development Goals, and through these, we are contributing to create a thriving society in a thriving environment. The first of the UN SDGs looks to ensure healthy lives and promote well-being for all. Our bunker fuel testing and advisory services ensure compliance with the IMO's 0.5% and 0.1% sulfur caps, leading to cleaner coastal air and ultimately saving lives. VPS provides sulfur test data directly to the IMO, and our testing over the past 15 years has shown a 67% reduction in sulfur emissions, proving that the IMO MARPOL Annex 6 is working. Our fuel quality testing can be used to investigate the combustion characteristics of bunker fuel, advising the ship operator how to optimize the power generation of the engines by adjusting the fuel injection and the air-fuel ratio. This ensures complete fuel combustion without leaving residues such as soot, hence reducing the emissions. We help ship operators ensure safety of life at sea via our flashpoint testing, which is a key parameter under SOLAS, plus our emergency equipment testing, where we ensure the fuel within onboard emergency equipment is fit for purpose, has not deteriorated in any way. So our fuel quality testing and our oil condition monitoring services provide protection against the breakdown of main and auxiliary engines at sea. FQT and OCM can assess the condition of critical equipment on board the vessel, such as main propulsion and power generation, including safety critical equipment such as emergency generators, emergency fire pumps, and lifeboats. The next UN SDG looks to ensure access to affordable, reliable, sustainable, and modern energy for all. VPS are involved in numerous R&D projects to support the development of green marine fuels using our marine fuel testing capability and advisory knowledge. We are also involved in sea trials to assess the adoption of these new fuels, applying our experience and knowledge to overcome technical difficulties that are often encountered on burning new fuels. Over the past 12 months, we've seen an increasing interest from the bunker industry regarding biofuels as a marine fuel option. But what is biofuel? Well, a key component is FAME, fatty acid methyl esters. These can be produced from a variety of oils and fats. And these oils can be derived from crops such as rapeseed, palm oil, soybean, and sunflowers, or they can be produced from waste oils and fats, such as used cooking oils or animal fats. Other biocomponents are HVO, hydrogenated vegetable oil, and HEFA, hydroprocessed esters and fatty acids. These come from a similar range of feedstocks as FAME, and their production process makes it a fully hydrocarbon, no oxygen present. There are actually currently 3 classes of biofuel. The first generation biofuels are made from crops. The typical carbon dioxide reduction can be anywhere between 35 to 60%. The second generation biofuels are made from waste products. The typical CO2 reduction here can be as high as 85%. The third generation biofuels are made from algae, and typical CO2 reductions can be anywhere between 70% to 90%. The drive for lower emission fuels will see a number of options coming to the market, and the following slide will show a few examples, where each of the fuels highlighted will provide lower CO2 than HSFO, VLSFO, and MGO fuels. However, every fuel has its pros and cons, and understanding these will help the decision-making process as to whether the fuel is right for a particular vessel and trade route. Firstly, as just discussed, biofuels will provide lower emissions in terms of greenhouse gases and carbon dioxide, SOx and NOx. Delivery of the fuel can be made through existing channels, and the fuel can be burnt in existing combustion engines with lower environmental risk. However, the downside of biofuels is that they are prone to water contamination and therefore more microbial contamination. They have longer-term storage issues as they are less stable, and at present they are relatively high cost. LNG has been on the market for some time now as a fuel that offers low emissions of SOx, NOx and particulate matter. It too can reduce CO2 emissions relative to the more traditional fuels. It doesn't require any exhaust gas treatment either. However, the downside of LNG is that the boil-off rate actually negatively affects the quality of the remaining LNG. Plus, methane slip due to unburned methane is far worse as a greenhouse gas pollutant than CO2. The handling of LNG is more difficult as it requires cryogenic handling. Plus, the infrastructure is still not there for high volume delivery, although it is actually improving. Methanol is another potential fuel option. Again, it's low in SOx, NOx and particulate emissions and has a reduced CO2 level of emissions. Methanol is biodegradable, so that's another green advantage. Plus, it's widely available with a vast number of methanol production plants around the world. However, methanol has a flash point as low as 12 degrees and less than half the energy content of HSFO, VLSFO and MGO. Ammonia is a carbon-free fuel source which can be burnt in a combustion engine. However, it has to be stored as a liquid at -33 degrees or stored at room temperature at 10 bar pressure. It actually requires 3 times the volume of ammonia to equal the energy of HFO, and it's actually twice as heavy as HFO. In addition to all this, ammonia is a toxic substance. Hydrogen is another carbon-free option and with zero emissions. Its environmental attractiveness is certainly providing a high investment appetite. However, there is currently no infrastructure for this fuel. There are significant safety concerns also due to its reactiveness, flammability, and low ignition energy. Plus, it will require storing at very low temperatures and elevated pressures. The third UN SDG to consider is the need to take urgent action to combat climate change and its impacts. Marine fuel testing and advisory services can help ensure that the fuel is burned efficiently in the vessel's engines for optimum propulsion, minimizing greenhouse gas emissions. ISO 8217 analysis of fuel provides valuable information on improving ignition quality, ignition temperatures, and avoiding loss of engine efficiency. It can help avoid cold corrosion, hot corrosion, engine wear, and fuel pump seizures. Plus, it can also help avoid blocked pipework, blocked filters, and blocked exhaust systems, whilst also helping to reduce turbocharger deposits and fouling deposits. ISO 8217 can identify fuel stability issues, protect against sludge formation, choke purifiers, and assist in fuel storage issues. Plus, VPS's additional testing can identify chemical contamination of fuel. By combining fuel quality testing and oil condition monitoring results, we can accurately monitor the engine condition and provide guidance to the ship operator to optimize engine performance and further reduce greenhouse gas emissions per nautical mile. Oil condition monitoring services provide early warning of impending engine problems, supporting smooth and efficient operation by tracking changes in the lubricant quality. Smooth operation of the engine helps to optimize greenhouse gas emissions during the vessel's journey. We can perform scrape-down analysis of cylinder lubricating oil, which is consumed as part of the engine combustion system. This has a direct impact on the emissions, since the higher the consumption, the higher the emissions. Scrape-down analysis provides the operator with valuable information on ways to optimize the use of cylinder lube oil and greenhouse gas emissions. So, combined fuel quality testing and oil condition monitoring results can forecast potential fouling conditions arising from incomplete combustion and prevent increasing emissions and potential engine breakdowns. The final UN SDG covers the need to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. To this end, testing can help in the reduction of the acidification of our seas. By reducing atmospheric emissions, we can significantly reduce the amount of acid rain. With regard to pollution of our seas, as part of a bunker quantity survey service, surveyors can prevent leakages and spills of fuel during the bunkering process. The importance of data and monitoring within shipping has never been so important to prove compliance and to show continuous improvement. VPS have the largest fuel quality database in the world, which we use to support our clients in many aspects of their business. These include our regular client-specific fuel management performance reports, plus for fuel, our VLSFO insights, MyFuels, and PortStats packages. Whilst for lubricating oils, we have our MyLubes package. All the above allow benchmarking of the product received via benchmarking of test parameters, benchmarking of suppliers, and also ports, whilst also supporting compliance criteria and helping to improve operations and procurement performance. The IMO have increasing requirements for ships to monitor and improve their environmental impact. Recent draft new mandatory regulations to cut the carbon intensity of existing ships have been approved by the IMO's MEPC at the recent MEPC 75 meeting. These new draft amendments add further requirements to the energy efficiency measures in MARPOL Annex 6, Chapter 4. We were already aware of the Energy Efficiency Design Index to show new builds to be more energy efficient than the baseline, and the Ship Energy Efficiency Management Plan, which provides for ships to have in place a plan to improve energy efficiency through a variety of ship-specific measures. Then the latest requirements will include the Energy Efficiency Existing Ship Index. The attained EEXI is required to be calculated for ships of 400 gross tonnage or above, in accordance with different values set for different ship types and size categories. This indicates the energy efficiency of the ship compared to said baseline. Then the Annual Operational Carbon Intensity Index, CII. This is for ships of greater than 5,000 gross tonnage. CII determines the annual reduction factor needed to ensure continuous improvement of the ship's operational carbon intensity within a specific rating level. These latest amendments should be effective from 2023 and be reviewed for their effectiveness by 2026. In summary, we can see just how far international shipping has come on its voyage to reduce its environmental impact upon our world. But now, more than ever, international shipping is focused upon its environmental responsibilities and its sustainability targets. The IMO have and continue to address SOx, NOx, particulate matter, and VOCs emissions through MARPOL Annex 6, and have now laid out challenging carbon dioxide and greenhouse gas targets set for 2030 and 2050. Fuel choice will be the significant factor in achieving all emissions targets, with many current and future fuel and lubricant oil options to be considered. However, testing and advisory services will be key in monitoring emission improvements, along with data monitoring in order to provide proof of legislative compliance. So, fuel management will only increase in importance due to the degree of fuel diversity and the level of data monitoring in the drive for environmental compliance and zero greenhouse gas emissions. I thank you for your kind attention, and I look forward to any questions after this presentation. Thank you very much.